Hello and welcome to Chemistry Sensei. This is Shane speaking. Today we will be going through Bedok Green Secondary School Preliminary Examination 2018 Combined Science Paper 1. Before we begin, it will be good that you try these questions by yourself. These questions can be found in the link provided down in the description box below. Without further ado, let us begin. Question 1. Which apparatus is most suitable to measure 21.20 cm3 of hydrochloric acid? For these questions, you need to know the accuracy of each of the measuring instrument found in the options. Okay, for pipette, you need to know that pipette measures fixed volume of liquid. They can be in the 10.0 cm3 or 20.0 cm3 or 25.0 cm3. This depends on the size of the pipette found in the school laboratory. As pipette is used to measure fixed volume of 10, 20 or 2.25, option A cannot be the answer. Alright, how about option B? A burette can measure up to 0.05 cm3 of liquid. Okay. As it can measure up to 2 decimal place, which corresponds to the 21.20, which is also in 2 decimal place. That's what makes burette the correct answer. Option B. For measuring cylinder, it can measure up to 0.5 cm3. As it can only measure up to 1 decimal place, measuring cylinder cannot be the answer. For option D, electronic top pen balance. For electronic balance, it is usually used for measuring mass. Okay, so it is not a suitable equipment for measuring hydrochloric acid. Question 2. Which method is suitable for obtaining pure ethanol from wine? Wine is a mixture of alcohol and maybe other flavors and coloring dye. So it is a mixture of multiple substances. For that, the best technique we can use for separating pure ethanol from wine is fractional distillation. Fractional distillation is good for separating a liquid from a mixture of liquid. One good example is the separation of crude oil. Okay, so the best answer is option D. For question 3, an unknown white substance, unknown white substance was found on a murdered victim's body. A crime scene investigator conducted a series of tests on the substance. First, he dissolved the substance in water to form a colorless solution. So this implies that the substance is actually soluble in water. Right. Next, to a portion of the solution, he added aqueous sodium hydroxide dropwise. So this is a ionic test. A white precipitate was formed. The precipitate did not dissolve when excess sodium hydroxide was added. Okay, so let's take a look at aqueous sodium hydroxide. So we do not need to look at the transition metals, as transition metals give colored compounds. So we need to look at either ammonium, aluminium, zinc or calcium. So from here, we can conclude that the answer is calcium, because from the question, it is stated that the precipitate did not dissolve in excess sodium hydroxide. Okay, so it is insoluble in excess. So option A and B are incorrect. So the correct answer is option C. The reason being, all nitrates are soluble. Okay, all nitrates are soluble. Alright, it is stated in the first part of the question that the substance is soluble in water. For sulfates, not all sulfates are soluble in water. Alright. For question 4, which group of particle has 8 electrons in their valence shell? Straight away, I can remove option A, B, and C. The reason being, lithium ion and hydroxide ion do not have 8 electrons in their valence shell. Alright, so for lithium ion, it has a electrons configuration of 2. For hydrogen ion, it has no electron, because for hydrogen atom, it has a electron configuration of 1, and once this is removed to form H+, there is no longer any electrons left. So the correct answer is option D. Next question, question 5. An element has the electronic configuration of 2, 8, 4. What is the identity of the element? Straight away, we must know that this element belongs in group 4. Alright, so it belongs over here. And it has a proton number of 2 plus 8 plus 4, which is equals to 14. Alright, so the correct answer is silicon. The answer is option B. Question 6. Two elements react to form a compound with the chemical formula X2Y. This compound is able to conduct electricity when dissolved in water. As this compound is able to conduct electricity when dissolved in water, this tells us that this compound is an ionic compound. Ionic compounds, they have a metal reacted with a non-metal. Okay, so let's take a look. X definitely cannot be oxygen or nitrogen. It must be a metal. Oxygen and nitrogen are non-metal. So over here, we have chemical compound X2Y. So it means that it is formed from X plus and Y2 minus. So this is the reverse crisscross method that we use to find the charge of the species. So we bring these 2 over here up top to Y, and the 1 over here to the top of X. Over here is the positive charge, and here is the negative charge, because metals form ions by removing electrons to form a cation. Okay, non-metals on the other hand, they gain electrons to form an ion. So the correct answer is option A, because X loses 1 electron, so it must be from group 1. Okay, sodium is from group 1. For Y, it had gained 2 electrons, that means the species Y must be from group 6. And yes, sulfur is from group 6. Okay. Let us now move on to question 7. Question 7. Using the equation shown below, find the volume of oxygen needed to completely react with 36 dm³ of methane at room temperature and pressure. Okay, so over here we know that it will take 1 mole of methane to completely react with 2 mole of oxygen. Okay, so as these compounds are all in gaseous state, we can use this rule. Okay, the volume ratio is equal to the mole ratio. Okay, so that means if we have 36 dm³ of CH4, okay, so we have multiplied by 36 over here. So similarly, we should multiply by 36 for the oxygen. Okay. So 2 times 36 is actually equals to 72. Take note over here that the units are different. However, it is okay to do such conversion because of this rule, where the volume ratio is equals to mole ratio. Alright, so the answer for question 7 is option D. Question 8. In a village, before using a cast iron wok, lemon juice is used to clean the surface of the wok. Okay, this is because the correct answer is option C. The lemon juice is acidic, yes, and will remove the iron 3 oxide that is found on the surface. Okay, iron 3 oxide is formed on the surface of the iron wok because iron will react with oxygen found in the atmosphere. Alright. So we want to remove this layer of iron 3 oxide by using lemon juice, which contains citrus acid. Okay, so this is a acid-base reaction. Okay, so the correct answer is option C. Question 9. Aluminium oxide can react with both acid and alkali. What type of oxide is this? So this is a amphoteric oxide, because amphoteric oxide is able to react with both acid and alkali. It's not a basic, acidic or neutral oxide. Question 10. What result is obtained when liquid bromine is added to aqueous potassium chloride? So over here in potassium chloride, there is K plus and Cl minus. Okay, potassium has donated 1 electron for chlorine to form Cl minus. If there is a reaction, the bromine will displace the chloride in potassium chloride. This is done by forming potassium bromide. Okay, potassium bromide KBr has potassium ion and bromide ion. However, this reaction does not occur because chlorine is more reactive than bromine. Okay, as bromine is bigger in size because it is located below chlorine in group 7, it is more difficult for the nucleus of bromine to attract the electron donated by potassium. Okay, on the other hand, for chlorine, which is smaller in size, it is easier for the nucleus of chlorine to attract the electron donated by potassium. Thus, chlorine would react with potassium more preferably than bromine to form potassium chloride. Hence, as bromine is unable to displace chlorine from potassium chloride, there is no visible reaction. Question 11. Element Z has the electronic configuration of 2881. A scientist dropped a piece of element Z in cold water. What would his observation be? First, you must know that element Z is from group 1, alkali metals. The reactivity of alkali metals increases down the group. So the lower the element is located in the group 1, the more violent the reaction is going to be. Straight away, the correct answer is option D, where the element Z darts around the surface of the water, effervescence and sparks were seen. So this is a multivalent reaction. Now let us move on to question 12. Question 12. The diagram above shows the result obtained when 3 different metallic discs of the same shape and sizes were dropped into dilute hydrochloric acid separately. So there are 3 metals reacting with acid. So this is a metal-acid reaction. Which metal is likely to have been placed in each beaker? So for beaker 1, there is a vigorous reaction. So this suggests that the metal is highly reactive. For beaker 2, there is no visible reaction. So this means that the metal is located at the bottom of the reactivity series. For beaker 3, the reaction is observed, okay, but lower compared to beaker 1. That means that yes, this metal is reactive but not as reactive than the metal found in beaker 1. So in order to do this question, it's important for you to memorize the reactivity series of the metals. Alright, now I will introduce the method that helps me to remember the reactivity series. It goes as follows. Please send cats, monkeys, and zebras into large heavy cage. Soon go. Okay, so P is for potassium, S is for sodium, C is for calcium, M is for magnesium, A is for aluminum, Z is for zinc, I is for iron, L is for lead, H is for hydrogen, and the second C is for copper, S is for silver, and G is for gold. There are multiple methods out there, so this is the one that helps me the most. So let us go back to the reaction. This is a metal acid reaction. So metal acid reaction would form salt and hydrogen. So essentially, this metal is displacing the hydrogen found in the acid, for example, hydrochloric acid. So this hydrogen is being displaced by the metal. So for a reaction to go through, this metal must be more reactive than hydrogen, which is found at this portion of the reactivity series. So the metal must be higher in the reactivity series for the reaction to go through. So for beaker 2, where there is no reaction, that means that the metal can be either copper, silver, or gold. Alright, so straight away option C and D are incorrect. Next, by comparing between beaker 1 and beaker 3, we know that beaker 1 contains a metal that is more reactive. The correct answer is option B, as calcium is more reactive than magnesium. Now let us move on to question 13. Nickel is between iron and lead in the reactivity series. Which statements can be deduced from its position in the reactivity series? Option 1. Nickel forms effervescence with cold water. So if you have memorized the reaction of metals with cold water, you should know that this is incorrect. Reason being, the reactivity of the metal with water decreases down the group. So for iron reacts poorly with water. So if you are not convinced, maybe you can take a stapler bullet and run it down in the tap. Okay, so you realize that there is not a vigorous or visible reaction at all when the stapler bullet is being placed in running water. As the question has told us that nickel is between iron and lead, this means that nickel is even less reactive with water. Straight away, this reaction does not happen. There is no visible reaction. For option 2, nickel is obtained by heating nickel ore with carbon monoxide. Alright, so this is actually true. For the reaction, for the purification of iron ore to form iron, so we have hematite, which is Fe3O4. The purification of iron to obtain pure iron is by using carbon monoxide. The carbon monoxide would remove the oxygen found in hematite to form iron. So this means that actually carbon over here in the carbon monoxide is more reactive than iron, because the carbon would react with oxygen, would displace iron from the hematite. As carbon is more reactive than iron, so this also suggests that carbon is more reactive than nickel, as nickel is found below iron, which means that nickel is less reactive than iron. So yes, option 2 is correct. Next, option 3. Nickel reacts with dilute hydrochloric acid to produce hydrogen gas. Yes, this is true because nickel is found over here, so it is more reactive than hydrogen. The statement 3 is correct. Therefore, the correct answer is option C. Next, question 14. Carbon monoxide, sulfur dioxide, and oxides of nitrogen are all common pollutants of air. Which pollutant is shown with its correct source and its adverse effect on the environment? Carbon monoxide, yes, it is formed from the combustion of fossil fuel, but it does not cause acid rain. Alright, carbon monoxide is a neutral oxide. Alright, it is a neutral oxide. Next, carbon monoxide is not formed from lightning. It is formed from combustion of fossil fuel. However, oxides of nitrogen is formed from lightning, and it does cause acid rain because oxide of nitrogen is acidic. Right? So yes, option C is the correct answer. Option D, sulfur dioxide. Yes, it is produced from volcanoes. However, it does not cause global warming. Alright, sulfur dioxide is not a greenhouse gas. Question 15. Ammonium chloride was added to distilled water. Which graph correctly shows the change in temperature? Okay, for this reaction, ammonium chloride is dissolved in water, so it would form ammonium ion and chloride ion. Alright, this reaction is stable because water is able to help stabilize the charges through ion dipole interaction. Okay, there is an interaction between the ammonium and chloride ion with water. Alright, so if you take a look, this reaction is actually bond breaking. We are breaking the bond between ammonium ion and chloride ion. Alright, so in order to break a bond, energy is required to be absorbed so that the bond can be cleaved. Alright, so when the ammonium chloride is absorbing energy is being removed from the environment. That means that the temperature of the environment actually decreases. Alright, so the correct answer is either option C or D. A and B cannot be the answer. Alright, however, the correct answer is option D. Option C cannot be the answer because eventually the temperature will be back to the normal room temperature. Alright, just like after you have on your air conditioner for a while, eventually the temperature will go back to normal room temperature. Next, question 16. Acidified potassium manganate can be used to detect the presence of ethanol vapor in the breath of a person who has consumed alcohol. If ethanol is present, a color change is observed. Why is the color change observed? Straight away, the correct answer is option B. Alright, as potassium manganate is purple in color, once a reaction has taken place, it will change to colorless. Alright. Excess magnesium was added to a beaker of dilute hydrochloric acid on an electronic mass balance. A graph of the mass of the beaker and contents were plotted against time. Okay, over here we see that the mass of the beaker in reaction 2 is smaller than the mass of the beaker in reaction 1. This means that more compounds are reacted away. Alright, so which of the statement proves this? Okay, for statement 3, a decrease in temperature only reduces the rate of reaction. It does not change the amount of product formed or the amount of reactant left. Okay, so statement 3 cannot be the answer. How about statement 2? The mass of magnesium but in smaller pieces. So this actually increases the rate of reaction. Okay, similarly, this does not affect the amount of product formed or the amount of reactant left. Alright, so you might be wondering, why does cutting the magnesium into smaller pieces increases the rate of reaction? This is because there are more surface area being exposed to hydrochloric acid. Okay, so we have big particles like this. Okay, so the surface area is over here. Alright, however, when you have multiple small particles, there are now more surface area being exposed to hydrochloric acid. Alright, so we have over here so this actually speeds up the rate of reaction. Now, how about option 1? The same volume of a more concentrated solution of hydrochloric acid. So yes, this will indeed increase the rate of reaction. More magnesium will be reacted away. Why? More concentration means there are more particles of HCl present in the same volume. Okay, so if there are more HCl present, you will react with more magnesium metal. So take note that excess magnesium is being used. So when you have more HCl, more magnesium is being reacted away, and this will cause the amount of reactant left to be lesser. So the correct answer is option A. Next, question 18. A compound with molecular formula C2H4O2 dissolves readily in water to form an aqueous solution. When this aqueous solution reacts with magnesium and limestone respectively, bubbles of colorless gas are observed. What is the structure of this compound? Immediately, you must know that this compound is a carboxylic acid. Okay, why is that the case? It is because there is acid metal reaction and acid carbonate reaction. So the only organic compound that you have learned that is able to react with magnesium and limestone is carboxylic acid. So carboxylic acid has the formula C double bond O OH. So which of these compound A, B, C or D has a structure like this? The correct answer is option A, where we have a C double bond O and a OH. Option A is the correct answer. Next, question 19. The diagram shows the structure of a monomer. So a monomer is a repeating unit. Okay, so this is the repeating unit. So which polymer can be formed from this monomer? So simply, we just copy the monomer. So we have C, H, F, okay, C, Cl, F. Do take note that for polymerization, the double bond is changed to a single bond. Once this double bond is being broken, now there are additional bonds to connect the monomer. Okay, so we have another CHF, CClF. So this goes on and on. So which of these option A, B, C or D looks like this? So let's take a look at option A. We have H, C and F, followed by Cl, Cf. Do take note that option A is incorrect because there are two fluorine atoms on the same carbon. However, from the one that we have drawn, there is only one fluorine atom on a single carbon. Next, how about option C, where there are two Cl on the same carbon? Again, this is incorrect because over here, for every monomer, there is only one chlorine atom. Alright, so option C cannot be the answer. How about option B? Option B looks promising because there is only one fluorine per carbon atom, which is similar to what we have drawn, and there is only one Cl, one chlorine atom per repeating unit. So the correct answer is option B. Option D is wrong because there should be fluorine attached to each carbon. However, there is no fluorine attached to each carbon in option D. Last question, question 20. What is the structure of the product formed when ethene gas is passed through aqueous bromine? So we have a ethene gas. So ethene looks like this. Okay, we have C2H4. Bromination of alkene occurs when an alkene reacts with bromine liquid. So for this reaction to occur, the double bond is broken so that the bromine atom can be incorporated to the alkene. Okay, the final product is a bromoalkane. Okay, no, there is no longer a double bond, so that it is no longer called an alkene, as this is a saturated compound. That's why it is known as an alkane, but more specifically, this is known as a halogenoalkane. So which of these answer is correct? Option A is wrong because there is only one bromine. Option B is also incorrect because the two bromine atoms are located on the same carbon. However, for the product that we have drawn, the bromine atom is connected to different carbon atoms. So the correct answer is option C. Thank you for watching up till here. I hope you have enjoyed the video and have learned something new. See you soon.